Good morning, children. So let us continue the topic periodic classification. So in the previous session we ended with what just discussing about the limitations of Mendeleev and how they could be rectified. So what was the means to rectify the drawbacks in the Mendeleev's periodic table? As per his law, the chemical properties and physical properties of the elements are the periodic functions of their atomic mass. So when this atomic mass was replaced by atomic number, we saw that many of the anomalies of Mendeleev were rectified. Now, how come this atomic number helped in rectifying the errors of Mendeleev's periodic table and helped in founding out the new modern form of periodic table? Now let us know what is atomic number. As you all know, atomic number is nothing but number of protons that is almost equal to what a number of electrons. So as per the new periodic law, the chemical and the physical properties of an element are periodic functions of their atomic number. Now how atomic number was used as a criteria to arrange the elements in a periodic table. Now when I say atomic number, let us now talk about what are the electrons. Now in your previous 9th standard you learned that electrons are arranged in every element in a set pattern. Okay, so now where are these electrons arranged? They are arranged in a particular path. Okay, you have learned that as per the Rutherford's model, you all know that there is a nucleus in the center in which neutrons and protons are located, around which a particular path is followed by electrons. Okay, now these paths are called as what, children? Orbits. Orbits or orbitals. We also call them as what? And orbits or energy levels, isn't it? Now each of this orbit indicates what? That electrons will be traveling in this set particular path. Fine. And but then orbits are only what? Energy levels, and each of this energy level is given a certain value. So the innermost energy level is represented as K. Then the next to it is represented as L. We will represent it in the capital letters. It is represented as what, children? L. And the next is represented as M, and so on. Now these orbits are the paths. Now in the sense the electrons will be traveling in this particular path. Now each of this orbit will contain a area called as orbitals. Now what are these orbitals? These orbitals are where the electrons are found to revolve. Okay, electrons are present in maximum concentration, where there is a probability of finding the electrons in maximum amount. Okay, so these are every shell. Now these orbits are also called as what, children? Shell. So we can call it as K shell, L shell, M shell, isn't it? Now you all have learned this. Just let us have a recap. So each shell will have orbitals, or which are also called as what, children? Subshells. Which are also called as what? Subshells. Now these subshells are the areas where you have a probability of finding the electrons. Okay, so now how many number of orbits, those many number of subshells will be present. Okay, now each orbit is given a value. If I take up K is equal to 1, L is equal to 2, M is equal to 3. So that means K, where its value is 1, so the number of subshells or the number of orbitals are also equal to how many? 1. Similarly, L, the value is how much? 2. So even the number of subshells are how many? 2. M is equal to 3 subshells. Clear, children? So now the question comes, what are these subshells? Now as I told, they are we have a maximum probability of finding the electrons. Now basically there are 4 types of subshells. How many types of subshells, children? 4 types of subshells. Now these subshells are designated as S, P, D and F. How many subshells? 4 subshells. S, P, D, F. and each subshell has a capacity to hold a fixed number of electrons. Okay, children. So now let us take S. Now S has a capacity to accept how many electrons? 2 electrons. P has a capacity to take up how many electrons? 6 electrons. D has a capacity of taking up 10 electrons, and F has a capacity of taking up how many electrons? 14 electrons. So children, we have learned that orbitals are of how many types? Are 4 types: S, P, D and F, and each orbital has a certain fixed capacity to hold the number of electrons. Fine. Now children, all these orbitals will not be present in all the shells. Now, how many orbitals will be present in each shell will be represented by the value. Like now, as I told, every shell is given a value. Like let us see, K is given a value of 1, L is given a value of 2, M is given a value of 3. So accordingly, then those many number of shells will be there. So if I take up, for example, K, how many subshells will be there? Only one subshell. That is which subshell? S. Okay, so that means K shell will contain only S subshell. Now L value is how much? 2. So that means how many subshells it will have? 2 subshells. And what are those 2 subshells? S and P. The order will be first S followed by P, then D and then F. So L will have S as well as P. Then coming to M. M value is how much, children? 3. So that means 3 subshells it will contain. S, P, D. S, P, D. Similarly, N. N value will be how much, children? 4. So it will have S, P, D and F subshell. Okay, children. So now the electrons in every atom will be occupying these subshells in a particular shell. Okay. Then the question comes, how the electrons will be arranged in an atom. Now the electrons in an atom will be arranged from the lowest energy level to the next higher energy level. So that means the first electron of any atom will enter into the innermost shell, which is the least energy level shell. So every atom will have its electron first entering into which shell, children? K. Once the K shell is filled, okay, then it will go into the L shell, and after L it will move to M, then to N. Now again, within the shell, for example, K has only one subshell. So that means electrons will first enter into what? S subshell of K shell. Then coming to, once this is filled, they move on to the L orbit, in which subshell will be filled first? The lowest one, that is S, then followed by P. Similarly, M, S, P, D. Similarly, N, S, P, D, F. So in every atom, the electrons first enter into the lowest energy level, then go to the next higher energy level. So you see now, children, the electrons in an atom are going to enter into a particular shell. That means they are getting arranged in a certain order. So this arrangement of electrons in an atom is only termed as what, children? Electronic configuration. Okay. The periodic arrangement of electrons in an atom is called as what? Electronic configuration. Now, how are these electrons arranged in an atom? They are arranged in an order. Okay, and what is the order? Electron first enters into the lowest energy shell and then goes on to the next higher energy levels. Okay. So now this electronic configuration only, which was devised, has helped us to arrange the elements in a periodic table. Now this was proposed by whom? By Niels Bohr. Now about atomic number, it was proposed by whom? By Henry Moseley. And then electronic configuration pattern was given by whom? By Niels Bohr. Then the pattern, the order in which the electrons should be entered, the sequence was given by another scientist by name Muller. Okay, which is also the diagram we'll be discussing later. So that is why now the modern table is not given a name of a particular scientist, rather that it is called as what? A modern periodic table or long form of periodic table, which is now purely based upon what? Electronic configuration. Now the question comes, how do we write an electronic configuration? Now this electronic configuration is written by following a certain rule that I'll discuss a little while later. Now before we move on to that, let me just tell you. Now we know that each shell has a subshell. That now from the, and you all know every subshell has a fixed number of electrons. So by counting the number of subshells, we can also come to conclusion how many electrons will be accommodated. Now for this, a simple formula has been devised, I think, which you have learnt in your previous standard, which is called as what? 2n square, where n represents the shell, okay, and the value of the shell. Now like suppose k has value how much? 1. So that means how many electrons it will accommodate? It will accommodate 2. Come over here to L. L value is how much? 2. So now S has a capacity of 2, P has a capacity of 6. And if I put it into this formula of 2n square, you know 2 into 2 square is equal to 8. Now the same value, see 2 plus 6 is equal to 8. So have we got it? Yes. Now come over here. Similarly in M. M value is how much? 3. So 2 into 3 square. So that is equal to how much? 18. So let us see whether this 18 electrons is correct or not. So S can accommodate how many children? 2. P can accommodate how many? 6. D has a capacity of 10. So if you sum up, it becomes equal to how much? 18. So our electronic configuration also gives us an idea about the total number of electrons that can be accommodated. Fine. So electronic configuration will tell you the total number of shells, okay, then type of subshells, and total number of electrons. So when we know the total number of electrons, automatically we also come to know the the atomic number, and of course the element, and accordingly these being given a place in the periodic table. So now here children, let us see the diagrammatic representation. Now if you see, each atom will have the orbits. So now here if you see, all I have represented in 3 different colors. So each shell I have represented in different color. Now if you see the K shell, I represented only with one line, one part. That means it is one shell and containing only one subshell. Coming to L, how many lines I have represented? 2, indicating what? 2 subshells are present. Coming to M, 3, that means 3 subshells are present, and 4 subshells are present. Now if you see this in the linear fashion, as I told you, what all information you get from the electronic configuration? First you come to know the type of the shell. So we know what is my shell? K shell. And then I come to know the type of subshell. What is the type of subshell present in the K shell? S. Then total number of electrons. How many electrons? 2. Okay. So then coming to L. So a shell is L. The number is what? 2. And how many subshells? 2 subshells. And how many electrons? S will have 2 and P will have 6. So altogether how many is equal to 8. Similarly M. Subshell, shell, third shell. Okay, this is first shell, this is second shell, and this is third shell. Third shell. And how many subshells? 3 subshells. And what are those 3 subshells? S, P, and D. And how many electrons? S has how many? 2. P has how many? 6. And D has how many? 10. So altogether how many? 18. I hope now these representations must have made it clear for you how the electrons are arranged in the shells. Okay children, so this is how the arrangement pattern will be followed. So starting from which shell? 1. then to second, then to third. And when I enter 1, it will be S. When I enter again the second shell, first I go to the smallest subshell, that is S, then to P. Similarly, even in M, I will go to the least subshell S, followed by P, and then D. So this is how electrons are filled. So further, we'll continue our discussion in this regard in our coming session. Thank you. Have a good day.